Okay, guys, we are now at 4.3, the final one, and this is understanding number 10. And we're talking about animals such as reef-building corals and mollusks. Those are your oysters, your clams, your animals that have hard shells. They have hard parts that are composed of calcium carbonate. This calcium carbonate will, when the animal dies, will fall down into the bed of the ocean that you see there. So when the animals that are living here die, their hard parts fall down into the ocean floor. When they fall into the ocean floor, they get compacted because you have more sediment falling from various places onto the ocean floor, so it's building up. And so these calcium carbonates get pushed together, and so they have an increase in pressure. With that increase in pressure is going to come a bit of heat, and all of that is going to cause for the compactation and the cementation of the minerals and rocks here from the animal shells, and they form something that we call limestone. Limestone is a sedimentary rock, and it is made from basically the parts of dead animals, the hard parts of the dead animals, the seashells. So it's the mollusks and reef-building animals, and other minerals from the earth itself, and they're cemented together through heat and pressure, and they form quite a large amount of sedimentary rock on our planet. So the carbon is leaving the animal and going into a stored form in the sedimentary rock. So far, we've looked at all of these various ways that carbon is recycled. So these processes that we've talked about, we have combustion, volcanic eruption, we have combustion from fossil fuel emissions, we have emissions from animals, we have carbon dioxide emissions, so you can have waste methane emission or CO2 emission. You have emissions again from the animals in the ocean. You also have absorption, where absorption is through photosynthesis, and you also have absorption in the carbon dioxide in the water, this exchange of carbon dioxide in the water. So all of this forms a nice cycle, and you will have to be able to reproduce and draw this cycle. So I'm going to discuss this at the end of the video. So scientists are able to estimate the quantities of carbons that are being moved around in these processes that we're talking about right here: photosynthesis, cellular respiration, combustion. Then we have our storage here. You have the absorption of carbon dioxide in the ocean, the emission of carbon dioxide from the ocean. So in these processes, scientists are able to estimate the carbon flux. And the carbon flux is the rate of exchange of carbon from one of these sources through one of these processes. So the arrows represent the processes and the blocks represent the sources. So notice that these carbon fluxes are expressed in gigatons. And that is because there is so much carbon. We're talking about such large volumes of carbon. The only way they can realistically talk about them is in gigatons. That's very important that you know that fluxes are measured in gigatons of carbon. And so here you look at the ocean surface and you're seeing what is being released carbon-wise from the ocean surface and what is being taken into the atmosphere. And if you look here, you see 102 gigatons are going from the atmosphere to the surface of the ocean. But you see 100 gigatons are leaving the surface of the ocean and going into the atmosphere. So you're having a net gain of gigatons of carbon. So again, fluxes are a way for scientists to measure the carbon absorption, or the movement rather, not the absorption, but the movement of carbon through their sinks or their pools, and that's what we're looking at here. Okay, so one of the ways that we can measure the amount of carbon, because remember it's such a huge amount, and when we're talking about our atmosphere, how do we measure this? How do we measure the carbon in our atmosphere? Well, for over the last 50 years, it's been since 1956, there's been a monitoring station on Mauna Loa in Hawaii. It's briefly taking a hiatus because of the erupting volcano right now. But it's been monitoring the carbon, the CO2 content in our air since 1956. So monitoring stations, basically, they collect the amount of carbon dioxide. They measure a set volume over a set period of time, and so they can get these measurements. And what you're seeing here is the peaks and troughs throughout the years. The peaks of carbon dioxide are actually the winter in the northern hemisphere, and the troughs of carbon dioxide are actually the summer in the northern hemisphere. And what we know is that in the summer of the northern hemisphere, we have a lot more vegetation on the northern hemisphere than we do on the southern hemisphere of the earth. And so during the spring and summer, you have a lot more green vegetation. So you have a lot more photosynthesis occurring in the summer months than you do in the winter months. So in the winter months, even though it is summer or spring or summer in the southern hemisphere, there's not as much vegetation in the southern hemisphere, and consequently, you don't have as much CO2 being absorbed or photosynthesis going on, and so you have a higher level of CO2 in the atmosphere. If you look at the trends, over time, what you're seeing here is that you've got the CO2 levels increasing as the years continue. So you see that since the Industrial Revolution, this pattern has happened where we're continuing to see an increase in the CO2 production over the years. The dots represent the average in the months, so you can see the monthly average. The black line represents the overall trend value when we average the peaks and troughs together. You see the trend value, but you can definitely see that we are seeing an increase. As time is continuing, we're seeing an increase in CO2 in our atmosphere. So you need to be able to read one of these graphs, and notice that when we're looking at the graphs, we're looking at parts per million, so that's ppm, and we're looking at that over time. And we're looking at the monthly mean CO2 concentration. So here, each one of these red dots is the mean, the average CO2 concentration. And if I average out the peaks and the troughs, I'm going to get this line here that shows you basically the trend line. And you can see that the trend line is indicating that we are increasing CO2 concentrations significantly each year.